Hello and welcome to another nostalgic math ramble. We are looking at the last question on the IEB May 2023 paper 2. Exciting stuff. Um, without further ado, let's get into it. So we have a diagram. Very paper 2. Paper 2 is just all sorts of beautiful pictures. Right, so we are on a Cartesian plane. O represents the origin. A is a point on the line with equation f of x is equal to negative 2x. Okay, so let's just highlight that for ourselves. Right, okay, jumping the gun a bit by assuming that O to A is a straight line, but we will correct ourselves if the information says otherwise. Okay, or if the information doesn't supplement that idea, right? But just based on the parallel line signs going on there, and there's a right angle there by BE. Okay, no, what does that prove? Well, yes, it proves that that is a straight line. No, it doesn't. Can't assume that AB and BO are in one straight line just yet. So you know what? But then there's this F label as well that's making me feel like they're telling us it is all a straight line. Anyway, okay. I am getting caught up in a very small detail. B is a point on OA. Perfect. Okay, so OA is a straight line and B is a point on that straight line. And we know that OB is square root of 125 units. Okay, so we're just going to fill that in. So this is square root 125. Okay, and then E is a point on the y-axis so that EB is perpendicular to OA, and they've filled that in on the diagram for us. D is a point on the line with equation G of x is equal to 2x, and C is a point on OD so that, okay, so wait, I'm just going to so we're being told the equation of that line is this guy. Okay, and we're told that C is a point on OD so that EC is parallel to OA. Okay, which they've also put on the diagram for us. Awesome stuff. So now we are asked to determine the coordinates of B. Wowzers with the trousers. Where to begin? Okay. So just to kind of recap some of the things that were said. So we know that this equation is y is equal to negative 2x, and we know that this one is y is equal to positive 2x. Okay. So we know that B lies on this line. So maybe let's use a less garish color. So let's say if the x coordinate of B is little b, right, then we know that the y coordinate will be negative 2b, right, just because it's on this line. Okay. Right, so this is appealing to me because what immediately came to mind for me about this B is if I draw this little triangle over here, okay, we already know that the x coordinate here is some number B, okay, and the y coordinate, right, is going to be negative 2b, and the minus might be confusing, but just remember that b is a negative number just because of where it is on the x-axis, so it's going to end up being a negative times a negative, going to end up being positive. Anyway, so the y coordinate here is going to be minus 2b, right? And so because we've been given the length of this side OB, we can do a bit of Pythag to figure out what b is. So we know that the length of this segment over here is, I don't know if you talk about absolute values in high school. I don't think so. But essentially, it'll be negative b units, right? And again, don't worry about this being a minus, because remember, b is a negative number. So just think if b is negative 2, then this length over here is not negative 2. It's going to be negative 2. It's going to be positive 2, right? And then this length over here will be negative 2b units. Okay, I'm going to stop laboring the point about the negatives. It actually even doesn't matter whether we put the minus or not, because as we know with Pythagoras, we're going to square, the negative is going to disappear anyway. So we're just trying to be technically correct, right? So then we can set up an equation in terms of b to then work out the value of b. Anyway, so let's write down all of this as a good coherent answer. So so let's just start by saying we know that if xb, the x coordinate of b is b, then the y coordinate of b will be negative 2b. Right? And so therefore, by Pythagoras, right, we're going to take this distance plus this distance, and we know that that's going to be equal to the hypotenuse squared. Let's just shrink this a bit. Yeah. Oh, all sorts of exciting things happen on this app all the time. I think let's just surrender this one. It's not coming back. Right, is equal to that guy squared, and that is because I'm just going to write it big over here and then shrink it. That is because of Pythag. Okay, right, and so we have just b squared plus 4b squared is equal to 125. We now have 5b squared is equal to 125. So b squared is equal to 125 over 5, which is 25. And therefore, b could be, well, plus or minus the square root of 25, which is plus or minus 5. But we know that the x-coordinate of b has to be smaller than 0, has to be negative. Right, and on the one hand, we're kind of relying on the visual cue to determine that, but on the other hand, even if they hadn't given us a visual cue, we know that y is equal to minus 2x looks like this, and we know that, how do we know that b is above? Yeah, it's just kind of suggested to us that way, that b is above the x-axis, right? Yeah, so really it's not all I'm trying to say is that it's not a reach to say that, well, we definitely know that b is on the left hand side of the x-axis, right? And therefore its x-coordinate is negative, so therefore b is actually equal to negative 5. Right, so we know that the x-coordinate is negative 5, right? And so therefore the y-coordinate we can figure out by putting it into the function f, right? So f of negative 5, which is negative 2 times negative 5, which is 10. And so the coordinates of b are negative 5 and 10. Okay, let's see whether the memo is in agreement. And yes, it is. Awesome potatoes. Right, so that question kind of relied on us just being comfortable with, the fact, what does a function mean, and a bit of Pythaggy waggy, or the distance formula, whatever makes you happy. I mean, those are one and the same. Right, so let's look at the next question, the next part of the question. I'm just going to quickly highlight. What do I want to do? You know what? Actually, let me duplicate this page so that I can have all the scribbles. Right, we don't want this anymore. Oopsie. Oi, can't move things. Oh, okay, let's hide that. Delete. Okay, now let's rub out all the stuff we don't need. Sometimes I just have these days where my fingers feel so big and they just stomp on everything in their way, and I end up clicking on things I really don't want to click on. Anyway, that's just a side note as we maneuver through this cleanup mission. Okay. And there was some more down here. Okay, no, don't want to delete that much. Okay, and then let's get the next question. Away we go. Okay, then we don't need this other page anymore. Awesome. Right. Thank you for bearing with me. So they do then give you that point so that even if you kind of made a mistake in the first part, A, you know to go back and correct it if you have time, but B, it's not going to jeopardize your chances of getting the second part right. Yeah. Okay, so we get a confirmation that the coordinates of B are in fact -5 and 10. And we're asked to determine the area of the trapezium OOBEC. Juicy. Okay, so the area of a trapezium, I don't think you get this formula on the formula sheet, but I just happen to remember that it is a half times A plus B times H, where A and B are the two parallel sides, and then H is the perpendicular height of the trapezium. But I'm going to approach this question as though we don't know that, because I think it's perfectly understandable that one might not know that. And it might make things slightly more challenging, but let's see how far we go. We go and we get. Okay, so well, do I okay, let's see. I'm just going to briefly chew a chip because I'm starving. Okay, so what I'm going to attempt to do, and then if I see that I'm buckling, I'm going to go back to my trapezium formula. But what I'm going to try to do is split the trapezium up into two parts, right? Because this trapezium, thankfully, is not one of those ones that has another triangular bit sticking out of there. So we can actually split it into two shapes, right? There's a rectangle over here, and then a right angle triangle over there. So if you can find the area of this guy and the area of that guy, then we're all good. So that's what I'm going to do first. I'm just going to split it up, right? So something like that. And we'll just call that point P, because why not? Okay. And that is a point that is, yeah, so we're dealing with 90 degrees over here and 90 degrees over there. Okay, so ECPB is a rectangle and CPO would then be a right angle triangle. And so in order to find the area of the rectangle, we would need to find out the length of BE, or the length of CP. And also the length of BP, unfortunately. Yes, because we don't know, we only know the length of BO. So there's that interesting complexity. So if we can find the coordinates of P, then we can find the length of BP, because we know the coordinates of B. So that's the one train of thought I'm having. Then we also need to find the coordinates of E, so that we have the length of BE. Okay, so I feel like I want to start with BE. So I'm just going to, just write down here so that the examiner knows where P is coming from. So I'm going to say construct CP such that P is a point on AO and CP is perpendicular to AO. Okay, so that explains where P is coming from. Right. That being said, I'm going to go back to trying to figure out BE. So let's start by trying to find the equation of BE, because we know that its gradient, the gradient of BE, is going to be the negated reciprocal of the gradient of this guy, right? Because they're perpendicular. And because the gradient here is -2, that means that the gradient of BE will be positive 1/2. And so therefore, the equation of BE is going to look something like y is equal to 1/2 x plus c. And we know the coordinates of one of the points on that line, -5 and 10. So we're going to sub in that point, right? So we know that y is 10, x is -5. So we've got 10 is equal to -5/2. And so c is equal to 10 plus 5/2, 10 plus 5/2. That ends up being 25/2, I think. Okay, so the equation of BE is equal to y is equal to 1/2 x plus 25/2, right? And we know that the c over here tells us the y-intercept of the line. So we know that the coordinates of E are therefore x is 0 and y is 25/2, or 12.5. All righty then. So that gives us enough information to work out the length of BE. So let's go ahead and do that. So let me shrink this. And this, if I can. I don't think I can, but I'm going to try. Nope, never mind, not worth the pain, not worth the agony. Right, so we are now going to figure out the length of BE. So BE is equal to, this is not well aligned. Let's try this again. Okay, right, so BE is equal to the square root of 25 over 2 minus 10 squared plus 0 minus 5 squared. I am having a very lazy day, so I am going to put this onto the calculator. If I can find the square root, jeez. Okay, right. Ooh, that is not what I'm... Is this all going underneath? Okay, I just got worried because the square root wasn't growing. Okay. So that's 25 over 2 minus 10. And 0 minus, which is just plus 5. All right, so we end up with, I'm just going to keep it in third form, 5 root 5 over 2 units, okay? Right, and then comes the pain of trying to hide this thing. Good. Okay, right, so let's shrink that. Okay, and I'm just going to fill it in here as well. So we have 5 root 5 over 2. Cool. So now I'm going to try and find the coordinates of P. And I almost feel like in order to do that, I'm going to need to find the coordinates of C. So my thinking is, if I can find the coordinates of C, then I can find the equation of this line. Then I can figure out the intersection of this line with this line, and that will give me P. So that's what I'm hoping to achieve here. So let's see if we can find the coordinates of C. Oh, well, we know that these lines are parallel, so that means the gradient, so let's change colors, the gradient of EC is equal to the gradient of AO is equal to, let me rewrite that so that it's far from the picture. So the gradient of EC is equal to the gradient of AO is equal to -2, okay, because EC is parallel to AO, right? And so we know that the equation of EC is going to be something like y is equal to -2x. Oh, and we have the y-intercept, perfect. The y-intercept, which is E, which is 25 over 2. Awesome stuff. Okay, but now how does this help me? Okay, so then to find the coordinates of C, I can do that by finding the equation of these two lines. Yay. What? Did I say? Not the equation. The point of intersection between these two lines. I hope that's what I said. Right. When I get excited, I start saying nonsense. Okay. So we're going to find the point of intersection between EC and OD. And we do that by just equating the two expressions for y, sorry. -2x plus 25 over 2 is equal to 2x. Okay. right? So then we've got 25 over 2 is equal to 4x. Divide both sides by 4. So we have x is equal to 25 over 2 divided by 4. And I think that'll just come to 25 over 8. Right, so then we know that the x-coordinate for C is 25 over 8. And then we can find the y-coordinate, right, by putting it into either. So we've got 2 times 2 times 25 over 8, if I'm putting it into this guy. And that gives us 25 over 4, right? So something we can just quickly do to double check that. Oh no, I was gonna say we could find the length of this and see if it's equal to square root 125, but that's a trap, because square root 125 is the length of this whole side. It's not just the length of BP. So never mind that lie. Right. So you now have the coordinates of C. And we can use that. Okay, so remember we said where we're trying to go is we're wanting to find the equation of PC so that we can ultimately find the coordinates of P. So time to shrink. Whoa, what's happening? You know, one of the most interesting things about my life is that I am an IT professional, and yet technology and I sometimes we do not see eye to eye. Okay, so we already know that EB is parallel to CP because opposite sides of a rectangle are parallel. Okay, so we know that that is parallel to that. And how do we know it's a rectangle? Oh my goodness. Assumptions were made. We know that it's a rectangle because, so we just need to justify that real quick. It's not too hard, right? So we know that it's a rectangle, so ECPB is a rectangle because okay, yeah, I'm taking too many shortcuts. Let's do this. So I was going to say we know that it's a rectangle because all the angles are equal to 90, but do we really know that? Do we really know that all of them are equal to 90? So we know that CP, okay, CP is C, okay, let's just, this angle over here we know is a 90 because that's how we constructed it. So that's kind of given. We don't need to state that. What we do need to show is that this is a 90 as well, and that is a 90. Okay, so we're going to say, well, angle E is equal to 90 degrees because of co-interior angles on the parallel lines EC and AO, which we were given. I'm just going to move this down for 2 seconds. Right, and then we also know that angle C will also be 90, and that could be because of the angle sum of a quadrilateral. Right, we know that those will always add up to 360. So that is the quadrilateral ECPB, or you could again use co-interior angles. But yeah, the point being, we therefore know that ECPB is indeed a rectangle because all interior angles equal 90 degrees. Right, and so now we can continue with our reasoning. So we therefore know that EB and CP are parallel. Awesome. And that allows us to, since we already know, we know the equation of EC, we know the equation of EC. We don't know the equation of EB. Oh, we do. We know that the equation of EB is y is equal to a half x plus 25 over 2. Okay, so then, but the most important thing is that we know the gradient is a half. So we can say the same for CP, right? So the gradient of CP will be equal to the gradient of EB, which is equal to a half, because EB is parallel to CP, right? So therefore, the equation of CP is going to be something like y is equal to a half x plus something, right? And then we can find the something by subbing in the point that we know on CP, which is C. So let's go ahead and do that. So sub in C, okay, and the coordinates of C are so as the y, we've got 25 over 4, and as the x, we've got 25 over 8. Okay, right, so let's solve for C. So we've got 25 over 4 is equal to 25 over 16, lots of 25s. And so C ends up being, I don't know, 25 over 4 minus 25 over 16 gives us 70. Whoa, that's such a weak 7. Struggling for its life. Right, so we get 75 over 16. Wow, this 6 really doesn't want to come together. Shame. Right, this is giving hieroglyphics a bit. Hieroglyphics. Okay, so the equation, so therefore the equation is going to be y is equal to a half x plus 75 over 16. So that's 4 comma something something. Right. Okay. Right, so that's the equation of this line. Okay, and we want to find P. P can be found by obtaining the point of intersection between this line and our yellow line, which is y is equal to 2x. So let's do that. But first, we shrink. Can I move this here? Okay, right, so we are finding the point of intersection between y is equal to negative 2x and y is equal to a half x plus 75 over 16. Whoa. So let's do it. So we're going to say negative 2x is equal to a half x plus 75 over 16. So that is negative, wrong. Negative 5 over 2x, right? If I subtract half of x on both sides. Right, and then we just divide both sides by negative 5 over 2. Sneeze, 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 coming along. Oh, and then it disappeared. The hurrah. Right, divided by negative 5 over 2. So that gives us negative 15 over 8. Right. And then, do we need the y-coordinate? I don't think we do, but for the sake of completion, let's do it. So we can use, I'm going to use the simpler one. Right. Which ends up being just 15 over 4, I think. Thank you, Kalki. Right, so we have now found the coordinates of P. So that is negative 5 over 2 and positive 15 over 4. Okay, wow, this is giving long walk to freedom, but we're doing it. We are doing it. So let's see what we still need. Okay, first let's shrink. Oh, shocking. Okay, right. So, how far are we on our quest of finding this area? Okay, so in our rectangle, we can find the length here because we have B and P, and we also have that length over there. Okay, so then, yeah, all we need is to find this, and then we're ready to find the area of the rectangle. For the triangle, yeah, okay, we need that length as well. And then over here, we can just find that by minusing this from root 125. Then we'll have this piece. Then we can do half base times height. So the end is nigh, guys. The end is nigh. Let us find the length of BP, right? So BP is equal to 10 minus 15 over 4 squared plus minus 5 minus 5 over 2 squared. And let's see what Kalki has to say about that. Oh, okay, 10 minus 15 over 4. Oh, what? Big finger problems, guys. Plus negative 5 minus, well, we know that that's a plus 5 over 2. Right, so we end up with 5 root 29 over 4. Okay, so that's the length of BP. And so therefore the length of OP is going to be root 125, right? Because remember, that's the length of BO. Oh, my undo is gone. Anyway, okay. Root 125 minus BP, which is 5 root 29 over 4. Okay, let's see what we get. So, root, right, okay. So, root 125 minus the previous answer. That is a very colorful answer. So that is negative 5 over 4 root 29 plus 5 root 5. Okay, they haven't really actually done much. They've just rearranged this. So actually, this is just as good as not even working it out. So I'm just going to keep it like that. Right. Okay. And then what we said is, okay, we need to figure out the length of CP. So CP is equal to BE is equal to 5 root 5 over 2 because opposite sides of rectangle are equal, right? Okay, and of course always nice to name which shape you're referring to, so it would be nice to say opposite sides of rectangle EBPC are equal. Right, so with all of those values now, we are in a position to work out the area of the trapezium at last. Right, so let's do it. So therefore, the area of trapezium ECOB is going to be equal to the area of rectangle ECPB plus the area of triangle CPO. Okay, so let's work out what each of those is. Okay, so the area of triangle ECPB is going to be BP, which we found to be that 5 root 29 over 4 times the length of CP, I guess, or CP or some B, something, some letter BE. Okay, so CP, BE, whatever. That is 5 root 5 over 2. And then for the triangle, if you're very diligent, you would first explain why that is a 90. Okay, that's because angles on a straight line. So I'm not going to be diligent, but it's always good to just don't assume things, right? And just rather be very explicit about where these values are coming from. How did you conclude that this is this and that is that? Anyway, okay, so this is in fact 90 degrees. So we can just say half base times height. Okay, so that will be half of OP. Oh, it's not going to fit. Whoa. What am I doing? Okay. Oh. Okay. I'm going to need to go to a new line for this one because it's a bit bombastic. So it's going to be plus a half times OP, which we said is square root 125 minus 5 root 29 over 4 times the height, which is CP. So that will be 5 root 5 over 2. Okay, and this is definitely a candidate for the calculator to deal with. So let them deal. Elevator music. Because this is going to take a while. This is the kind of stuff that when I was a teacher, I would just be like, somebody just crunch the numbers and give me the final answer because I don't want to deal with this. Of course, another prudent thing that you could have done is use, just calculate in increments, store the intermediate results on your calculator instead of doing one massive calculation right at the end. That definitely makes a lot of sense to me as an approach. But anyway, here we are with our long calculations. Okay, right, so I am getting as an answer 25 times the square root of 145 plus 20 divided by 16. In other words, 50,06 units squared. Well, square units rather. Oh, the moment of truth. This was a marathon. So I won't lie, I am fully expecting that I made a mistake somewhere. And that we are going to have to go through very agonizingly. Oh, this thing does not want to disappear. Calculator, don't get excited just because I used you quite extensively for this question, okay? So yeah, we might just have to go over everything again. But let's cross fingers that we don't need to. They get 50,8 square units. 50,8. I'm on 50,06. First of all, I just want to see that I rounded correctly. Second of all, I just want to make sure that I punched in all my numbers correctly. Okay, so 5 root 29 over 4, 5 root 5 over 2, a half times, root 125 minus 5 root 29 over 4 times 5 root 5 over 2. Okay, so very sadly, I have punched my numbers incorrectly. So now it is time to just double check that I have in fact done everything to my satisfaction. And if it does turn out that I still don't agree with the answer in the memo, then I'll go over what the memo's done and see if I can spot any differences from there. Okay, so let's do it. So, why doesn't want to select the hand, guys? I'm genuinely asking you why it doesn't want to select the hand. Don't allow. I don't know what I'm doing. I'm just trying to get the hand. Oh, guys. Why is life so hard? Oh, what's happening right now? I think it just has moments of hallucination, hey? Oh dear. I can't scroll. There we go. Okay, well, after all of that agony. Okay, so I'm just going to get comfortable for this marathon. Okay, so we started by constructing the line CP as a perpendicular line to OB and P being a point on OB. Okay, so that's where we started. Next up, we determined that the gradient of BE, okay, so I'm going to get my fancy pointer out. So we determined that the gradient of BE is positive a half because we were told that BE is perpendicular to this line and the gradient of this line is negative 2. So the gradient of this one would have to be positive a half. Okay, happy with that. Then we decided we want to work out the equation of BE, which would be y is equal to a half x plus c. Then we subbed in b in order to find what c is. So we got 10 is equal to a half times minus 5 plus c. So that's minus 5 over 2 plus c is equal to 10. And then c is equal to 25 over 2. I think I still stand by that. 20 is the same as 20. 10 is the same as 20 over 2. And if I add 5 over 2, then it becomes 25 over 2. So I'm still happy with that. Y is equal to a half x plus 25 over 2, as we have there. So that's the equation of this line. Then we determined the length of BE. We did that by subbing in the relevant points, 25 over 2 minus 10 squared plus 0 minus minus 5 squared. So that is a 5 squared, that's 25. 25 over 2 minus 10 is 5 over 2. If you square that, that's 25 over 4 plus 25. So that's 125 over 4. So that's going to be root 125 over 2. Okay, so I still agree with that, right? In a nutshell. Okay, so I'm still happy with that. So then we filled that in on the diagram as well. Okay, then the next thing we decided to do was we decided to determine, we determined that the gradient of EC is equal to the gradient of AO because we were told these lines are parallel. So that means the gradient of EC is the same as -2, right? So then the equation of EC is y is equal to -2x plus something, but we do know the y-intercept. We know that the y-coordinate of E is 25/2. Let's just double check that. Yes. Okay. So then, voila, just like that, we have the equation of EC. Then we decided that we wanted to find the coordinates of C, right? And we're going to find them by finding the point of intersection between this line and this line. So that's why we equated minus 2x plus 25/2 to 2x, the expression for this line. And let's just see that we solve that satisfactorily. So we have 25/2 is equal to 2x plus 2x. And so x is equal to 25/2 divided by 4, which is equal to, so that's the same as just timesing by a quarter. So 25/8 I'm happy with. So that's the x-coordinate of C. Then we found the y-coordinate, which is 2 times 25/8, which is the same as 25/4. Let's just double check it by putting it into this equation as well, just to see that we get the same y value. Okay, so we've got -2 times 25/8 plus 25/2, and we still get 25/4. So we know that we calculated that correctly. Okay, right. So we've got the coordinates of C. Then we wanted to find the equation of the line CP. So we started by saying, okay, we wanted to first show that this is in fact a rectangle so that we could show that these two lines are parallel. So we say that E is a 90 because of co-interior angles, and C is also a 90, again because of co-interior angles. And so we demonstrated that. Whoa, what have I done? Oh my goodness, what have I done? I'm so confused. Okay, I would definitely like to know what I did at some point in my life. So we found that, okay, that quadrilateral is in fact a rectangle, which then allowed us to say, yeah, EB is parallel to CP. And so armed with that, we then knew that, okay, the gradient of EB is going to be the same as the gradient of CP because of them being parallel. And because we already knew that the gradient of that is 2, no, it's not 2, it's a half. So this would also be a half. The gradient will also be a half. So we have the equation of CP being y is equal to a half x plus c. Then we subbed in the coordinates of C, which we had found to be 25/8 and 25/4. So y is 25/4 is equal to a half times 25/8 plus C. So I'm just going to bring out the calculator for the solution of C. So that's going to be 25/4 minus a half times 25/8, right? And that does give us 75/16. So the equation of, okay, let's hide calc again. So the equation of the line this is so tedious. Okay, the equation of the line CP is y is equal to a half x plus 75/16. Okay, right, and we did all of that so that we could figure out the coordinates of P. So we figured that out by Oh, I was about to have a heart attack. Okay, so we did that by figuring out the point of intersection between this line and this line, which is y is equal to negative 2x. So let's see that calculation. Right, we've got negative 2x is equal to a half x plus 75 over 16. This, so minus 2x, if I minus a half x on both sides, I agree with that being minus 2.5x. So minus 5 over 2x is equal to 75 over 16. And then divide both sides by negative 5 over 2. So let me just try to do this one manually so that I don't do it on the calculator. So that will be the same as that. Okay, sorry, my laptop just needed a poke. Right, so that'll be that. And then these two will do that. So we end up with negative 15 over 8. Okay, which is what we got there. Right, and then to work out the y coordinate, we have we could put it into either equation. That gave us 15 over 4. Let's just put it into the other equation to verify. So that would be a half times negative 15 over 8 plus 75 over 16. So that also gives us 15 over 4. So that's promising. Right, so then now we had the coordinates of all these significant points. Right? Oh, guys. How did I decide that P is negative 5 over 2? The x-coordinate of P is negative 15 over 8, not negative 5 over 2. Okay, so now there's already... Sorry, oh man, this is such a bad habit. I need to stop sniffling. Okay, so this is probably where I made my mistake. So negative 15 over 8 is the x-coordinate and 15 over 4 is the y-coordinate. Okay, so now BP is going to be 10 minus 15 over 4 squared, that's correct. Then minus 5 minus, wait, oh, the agony. The agony. Guys, what is the moral of the story? What is the moral of the story? I need meaning to this mess. The moral of the story is just work. Copy carefully. Okay, so attempt number 2. I'm just going to do this to minimize my pain. I mean, I already am just in a lot of pain in general right now over my moomish ways. Okay, so this is actually 25 root 5 over 8. Okay, and then OP is going to be the root 125 minus this bit that we just worked out. So we're just going to keep it as that. Okay, and then we said CP is equal to BE, which is equal to 5 root 5 over 2, because opposite sides of a rectangle, not of a triangle, are equal. Okay, happy with that still. So the area of trapezium ECOB is going to be the sum of the area of the rectangle and the area of the triangle. And like we said, would be good to mention why CPO is a right angle. Okay, but now, okay, what I need to do is say BP, which is actually 25 root 5 over 8. times EB, right, times EB or CP, they are the same, okay, which is correct, 5 root 5 over 2. And then we're going to say half base, okay, which is this guy, OP. Okay, so let's write the correct value for that too. 25 root 5 over 8 times the perpendicular height, which is CP, which is that, okay, which is correct. I'm happy with that. And now let's see what we get. Oh no, okay, what I did not want to erase all of that. I just want to erase the number. The units can stay. So let's do this again. Okay, just going to set all of this up so that I can type one time. Okay, so this is 25 root 5 over 8, 5 root 5 over 2, root 125 minus 25, oh, this is another fraction, 25 root 5 over 8, and this is 5 root 5 over 2. And now I do indeed get 50,8-ish. I always just like 2 decimal places for these ones, unless they've explicitly said 1 decimal place. I don't think they did. Right. Yes, that is indeed matching what the memo said. Sorry for, well, I mean, I guess it's great that we got to go over the question twice. But yeah, to those of you who spotted my mistranscription, I hope you didn't sit through my redemption of 10 minutes. Yeah, thanks for tuning in, and let's get stuck in another exam. I'm so excited to be starting a different exam in the next video. Cool beans.